Hello everyone, my name is Amir and I'm excited to present our work titled NegRefine, Refining Negative Label-Based Zero-Shot OOD Detection. The goal of out-of-distribution detection is to identify inputs that come from unknown categories so that the model doesn't incorrectly classify them as one of the in-distribution classes. In this work, we focus on the zero-shot setting using the CLIP model. A common strategy for OOD detection is to design an ID scoring function which assigns higher scores to ID samples and lower scores to the OOD samples. By applying a threshold, we can decide whether an input is ID or OOD. Over the past few years, many methods have been proposed for zero-shot OOD detection. Among them, negative label-based approaches have gained special attention. Negative label-based OOD detection was first introduced in NegLabel. Their key idea is to create a set of negative labels by ranking the words in WordNet based on their semantic similarity to the ID labels, and then selecting the top % of the most dissimilar words. For a given image, they define a scoring function that compares the image's similarity to the ID labels and the negative labels. This score is computed using a softmax style aggregation over the similarity values from all ID and negative labels. This idea has been extended and refined in several follow-up works. Although negative label-based methods have shown impressive performance, they still face notable limitations. Considering how the negative label set is created, these methods relied on similarity to ID labels and a cutoff point of the top %. However, this approach can include subcategories of ID labels in the negative set. For example, consider this ID image with the true label Daisy. The label blue-eyed African Daisy is mistakenly included in the negative label set. This causes the image to be misdetected as OOD due to the higher similarity for this negative label. Another issue comes from proper nouns. Some proper nouns can be wrongly associated with ID images. For example, this beach image is incorrectly associated with Costa Rica, a proper noun, despite the image is not actually from Costa Rica. This again leads to the misdetection as OOD. Another key limitation lies in the detection score. The scoring function relies on the individual similarity scores for each ID or negative label. However, many images naturally match multiple labels. For example, this image is from the B class, but since there's also a flower in the scene, it has high similarity to the flower negative label. Similarly, this necklace image is associated with leaf-related negative labels because the shape of the necklace resembles a leaf. In both cases, the higher similarity for negative labels leads to these ID images being misdetected as OOD. To tackle these challenges, we introduced NegRefine. To handle the subcategory and proper nouns, we propose a negative label filtering mechanism. To address the multi-label matching issue, we designed a multi-matching aware scoring adjustment. Our first component is NegFilter, which automatically identifies and removes subcategories and proper nouns from the negative label set. To achieve this, we use an off-the-shelf LLM as an expert to detect these problematic cases. Our second component is a multi-matching aware scoring adjustment. To capture in-distribution images that also match negative labels, we create a caption-like text by combining ID label with a negative label. For example, for this image, we combine the ID label B with the negative label Tixit Sunflower to form the text B and Tixit Sunflower. If the similarity score for the concatenated text is significantly higher than the similarity for the negative label alone, it tells that the image is in distribution. To formally define our scoring function, we first select the top k ID labels and top k negative labels that best match the image. We then combine each ID label with each negative label, resulting in a total of k2 multi-matching texts. Using these, we compute our multi-matching score SMM. Finally, we define our overall detection score as a combination of SNEG label and SMM. Our experimental results show that NegRefine significantly improves upon previous clip-based zero-shot OOD detection methods. Thank you very much for your attention.